This is John Page Williams with another reading from Chesapeake Almanac. The month is November. This chapter is How Oysters Eat and What They Mean to the Bay. It's hard to empathize with an oyster. Not that we never have the chance. Shucking them and eating them on a half shell gives us plenty of opportunity to examine the animals, but their body plans are so different from ours that it's difficult sometimes to remember that they share the same basic processes of life with us. How do oysters eat? It's easy enough to forget that they eat at all. An oyster on the half shell is a mass of gray and tan tissue. There's no feature there that resembles anything human, as there is in a bird or a fish or even a crab. In the center is a muscle, the adductor, used to close the shell and hold it shut. Around the adductor is a large rounded digestive sac that may, on close examination, show some fluid circulating. And there are gills, 4 flat layers of tissue that lie in a long curve beside the digestive sac, forming a band between it and the shell. Tiny ridges radiate across the gills from sac to shell. This much is visible at a raw bar. But the system that fattens the oyster enough to get it to the raw bar is remarkably complex. The animal is an intricate system of pumps and filters. It is capable of straining 50 gallons of water a day, all the while discriminating between what is edible and what is not, ingesting what is and discarding the rest. Heavy sedimentation of its bed can choke it, though it can deal with some suspended mud particles and reject them. The central part of the gill system is a coordinated group of cilii, tiny hairs on the gill surface that wiggle in concert. Some of them set up the currents that bring water and suspended particles in between the oyster's 2 shells as they are opened slightly. Other cilii capture light organic particles in the water, while heavier inorganic particles fall into the troughs between the gill ridges. Organic particles is a very general term. For the oyster, it refers to phytoplankton, bacteria, and detritus, decayed but once alive material. Phytoplankton appear to be the most nutritious and therefore the most desirable food. Inorganic particles mean fine mud that usually suspended in the water close to the bottom of oyster beds. When these particles fall into the gill troughs, mucus glands stick them together in globs called pseudofeces, which are carried by the water currents to the edge of the shell and dumped out. The lighter food particles, meanwhile, are carried from ridge to ridge across the top of the oyster. The sorting system is not perfect, so some sediment is carried too, but most of it is eliminated. Near the top of the oyster are 2 pairs of palps, folds of tissue like the gills, but smaller. They cover the mouth. The palps have ridges and cilia too, but they also have chemoreceptors which can taste food. Further sorting occurs here. The cilia sweep food toward the mouth, but the troughs between the ridges are wide, and any particle whose taste the oyster does not like will be allowed to fall into them to be coated with mucus and swept out. When a preferred particle comes across, the oyster can close off the troughs, allowing the food to pass to the mouth. By this time, the food is caught in strings of mucus, which may be wound into the mouth and the digestive sac by the crystalline style, a protein rod that rotates in the sac. Some food is broken down and absorbed on the crystalline style and the inner surface of the digestive sac. But with water passing through the oyster in huge quantities, it's all too easy for food and digestive enzymes to be carried out and lost. Thus, much of the digestion is done by special cells that engulf the food, digest it within their cell membranes, and pass proteins, sugars, and fats onto other cells that need them. For a filter feeder, summer should be a prime time since the water is thick with phytoplankton and other oyster food. In fact, however, it is a hard time for oysters. They're spawning for most of it. It's a big effort since a prime female may produce 10 million to 100 million eggs in a summer. And toward the end of the season, dissolved oxygen levels in their waters are often low. Spawning and low oxygen cause them stress, especially on the deeper bars. Fall brings relief as the dissolved oxygen levels at the bottom increase. Though temperatures fall slowly from September to January, the water is the warmest at the bottom where the oysters are. They can feed down to a temperature of about 5 degrees Celsius, or 41 degrees, which means that in all but the coldest winters, they're feeding right through December. There's plenty of food, algae, leftover detritus from summer, and debris from the fall blooms of zooplankton. With the metabolic demands of eggs and sperm production at low levels, the oysters can use most of their food to fill out and fatten up. Cold weather helps keep them firm. They will cease feeding when the winter really shuts in and live on their reserves of fat, glycogen, which is animal starch, and protein. Quality of meat will drop slowly till spring. The drop will not be enough to make them unappetizing, but they will not be as plump then as they are now in December. It is a happy coincidence that just as the weather gets chilly and our bodies start needing sturdy food like oyster stew, scalloped oysters, and a dozen on the half shell, the oysters themselves are in prime eating condition. The oyster's eating system is well adapted to concentrating food even in a poor environment. Thus, it is no wonder that a rich estuary like the Chesapeake has produced so many of them. For literally thousands of years, from the early woodland Native Americans through European settlement and up to the mid-1980s, the bay's oysters have been its most valuable seafood resource.